Very good morning to all of you. How are you? I hope you all are fine. So, as we are discussing about the alternating current, that the topic covers are the power of an AC circuit, wattless current, and the power dissipated. Right? Now, the topic that we have to discuss today is LC oscillation as well as your transformer. Now, both these topics are very important from the examination point of view. Okay, so understand it properly when I am going to teach you and go through the video so that proper understanding of the concept is formed in your mind. So, here we are going to discuss about LC oscillations. L stands for inductor, right, and C stands for capacitor. That means there is a kind of oscillation between inductor and capacitor, as the name indicates this one. Now the thing is this, yes, the oscillation will take place. Now how the energy is going to take place, let's discuss this. Let's say that we have an inductor. This is your symbol of inductor, right? Now this is your inductor and there is another thing, that is your capacitor. Okay, so what do you understand by this, that there is L and C, they are going to exchange what? They are going to exchange their oscillations. No, they will never going to exchange their oscillation. But what is the common thing in both of these? We studied in the previous topics that energy of the inductor is half Li square, right? Whereas the energy of the capacitor is half Cv square, right? Okay, so basically you can see that both the expression are somewhere common, because this is capacitor, so it is containing the C, and V is the voltage obviously, and because this is inductor, so that's why, and it depends on the current. So here not the oscillation exchange will take place in the inductor or capacitor. Common in the both case is energy. Okay, common is energy. Basically LC oscillation is nothing but it is the phenomena of oscillations of energy of inductor और capacitor. ओके, ऑसिलेशंस तो हैं, बट ऑसिलेशन किसकी है? ऑसिलेशंस ऑफ एनर्जी है, ऑफ किसका? कैपेसिटर और इंडक्टर का, राइट? सो व्हाट डू यू अंडरस्टैंड बाय LC oscillation? Means the oscillation of energy of capacitor or inductor. Now obviously this term arises when you have studied it in the magnetic field, but this term capacitor arises when it is in the electric field. So here the energy is in the form of magnetic field. Okay, but here in this form energy is in the force of, or in the form of, electric field. Okay, this is the difference between them, but energy is there, that is the common thing, right? Now how the LC oscillation work? Let's understand the concept. Let's say that we have a circuit in which the capacitor is present somewhere here, right, and the oscillations, or you can say the inductor, is somewhere placed like this. Okay, now what happened? This is your inductor, okay, and this is your capacitor. Okay, now what happened when the energy, this charger, or you can say this capacitor, is going to be fully filled in the case of initial, or you can say initially this capacitor is going to be fully filled, you can say, right? And this is your current flowing in this case. Now as the current is flowing from this capacitor to the inductor, what happens here? When the charge is going to cross from this capacitor to inductor, some of the magnetic field lines will cross through this inductor, because this inductor is going to behave as a solenoid, right? This is your positive, this is your negative, and you know that as the charge is going to be lost by this capacitor, some of the field lines, by the law of Oersted, that state that whenever the current is flowing through a solenoid, obviously it behaves like a solenoid, right? So the magnetic field lines will create here, right? Now as the charges is going to lost more and more by the capacitor, more energy is going to be supplied towards the inductor. In this way, when the case arise when the charge of the capacitor is going to be fully lost, right? So more of the energy is acquired by the inductor. After the situation comes when there is kind of lines acquired by the inductor, or you can say full energy is acquired by the inductor, and capacitor have the charge 0, right? So in that case what happened, the reverse phenomena is going to be followed. Now inductor will lose its energy and the capacitor will allow it to acquire. This is the kind of thing that is going to be take place here, or you can understand it like this also. Let's say that initially we have a capacitor like this, okay, and here your inductor is going to be like this, okay. Now this is the charge, obviously the electric field lines will be there from here to here, okay. This is your inductor, okay, and this is your capacitor, okay. Now the key is not going to be closed, key is open here, okay. So as the key is open here, the energy of the capacitor is given by qm square upon 2c. This is the another form of the energy, whereas the inductor energy is given by half Li square, okay. Because the key is open, so that means the inductor will not have any magnetic field lines. That means that this energy is going to be of 0, okay. This is the case when key is open, okay. Now if key is closed, then what happened? If the key is closed, in that case, let's say this is your inductor, okay, this is your inductor, this is your electric field here. Now what happened, the sum of the electric field lines, or you can say sum of the electric field lines, is now going to be less, because here the magnetic field around the inductor going to take place like this, okay. This is the magnetic field lines of the inductor. Now you can see here I have made 3 lines and here I have made 2 lines. What does it indicate? That there is a kind of charge is going to be lost from the capacitor and the energy is acquired by the inductor, okay. Now what happened, the third case arise when the charge of the capacitor is going to be empty. C is empty, okay. So in that case no field lines will be there, okay. So in that case, like this, all of the energy is acquired only and only by the inductor, because all the charges are being lost by the capacitor. So here energy of the UB is going to be maximum, okay. Now the third case, now this will lose its energy, UB trying to lose its energy, okay. And finally what happened, capacitor restore it, okay, clear? So this is the thing, okay. Now this is the thing what you have to do is, okay, this is about the LC oscillation. Now let's understand this topic mathematically. Now what does it indicate? Now let's say at time t is equals to 0, charge will be equals to qm, okay. Now by the Kirchhoff's law, this will be equals to q by c. What is q by c? That is the voltage of the capacitor, okay, minus L di upon dt. This is called the back EMF, as you know, okay. That should be equals to 0. That means q by c is equals to L di upon dt. Now what do you understand by current? Current is the change of the charge to the change of time. here you can see the current will decrease, but here the charge is going to decrease but current increase. Now how? Let's see this. Let's say if a circuit have a current of, let's say, 2 ampere, okay, and increases to, let's say, 4 ampere. So if I want to calculate the final, that is 2 minus 4, initial minus final, that will be equals to minus 2. But because here minus sign is there, no, okay, minus, I am including here minus sign, okay, so minus of minus 2 will be equals to plus 2, okay. So that's why I am saying charge will decrease. Obviously charge is going to decrease, but the current is going to increase, okay. So in this case, if I put this value here, q upon c, that will be equals to minus L, and this is your d upon dt, and I have the value of minus dq by dt. You can see here. So q upon c, that will be equals to minus of L d square q upon dt square, like this, okay. And final expression if I want to write, that will be equals to d square q upon dt square, that is equals to minus q upon LC, and this will be equals to d square q upon dt square plus q upon LC is equals to 0. Now if you are observing this equation very carefully, it is equals to the this much equation, d square y upon dt square plus omega square y is equals to 0. This is the equation of the simple harmonic motion you have studied in the class +1, and here the oscillation of y is going to take place. If you have remembered that we have a pendulum here, let's say this is your pendulum, and that is the displacement acquired by the pendulum, that is y. So here the oscillation of the displacement is going to take place, no, but here the oscillation of the charge is going to take place. So these equations are going to be similar compared with the oscillation of a simple harmonic motion. So this is going to be same. Here you can compare 3 or 4, and when you are going to compare 3 or 4, what you have this one is going to be same, because these here charge, here displacement, no issue. Here will be compared, right? What it is, omega square will be equals to q upon LC. So omega square y is equals to q by LC. So omega square is equals to what? That is because y is equivalent to charge here, I am saying this, so we will replace it, okay, we will replace it. So that is y square over q by LC, okay, and q is also going to be replaced by y. You can understand this because y is equals to q, no, so that's why, okay. So y square is equals to 1 upon LC, and what it is, it can be written as y, that is under root of LC, okay. So in order to write the frequency, we will know that 1 upon 2 pi under root of LC. This frequency is called resonating frequency. Resonating frequency. Here root means square value of the current is having its maximum value, okay. The root mean square value of the value is having maximum, and the tuning of the radio or whatever the device is going to be sharp. Tuning of device is going to be sharp, okay. So electromagnetic waves have to travel with this frequency. Any electromagnetic wave have to travel with this frequency, so that the quality of the sound or video is going to be excellent, okay. So this is the frequency that should be required to tune any kind of device, whether it is a mobile, whether it is a TV, whether it is any audio. So this kind of frequency should be there in order to have proper communication. So I think that's enough for today. Thank you and have a nice day.